All right, so you want to build an Android app, huh? Not just any app, but one that's, built to last, one that can handle whatever you throw at it. Well, today we're going straight to the source, Google's Android developer documentation.
Think of it like getting a peek behind the curtain. Seeing how the wizards at Google think about building apps that are both robust and maintainable.
Love that analogy.
hmm
And you specifically asked for help understanding how to build a maintainable app. So we're diving into 4 key documents.
Starting with the Guide to App Architecture. It's like the foundation of everything.
Right, you can't build a skyscraper on a shaky foundation.
Exactly. And one of the first things it emphasizes is this shift away from cramming everything into activities and fragments.
Which, let's be honest, was the way we used to do things back in the Wild West of Android development.
It's true. But now it's all about structuring your app around data, persistent data models.
Okay, so instead of our data living in the digital equivalent of a flimsy tent, we're talking about building a fortress.
Exactly.
Yeah.
Those persistent data models, they become your bedrock. They're what make your app resilient, especially in a world where connectivity, well, it's not always a given.
Tell me about it. Offline first is the name of the game these days, and I'm seeing it everywhere.
And for good reason. The Build an Offline First app guide, it really digs into this, and it's all about anticipating those moments when your user is stuck in an elevator or maybe a tunnel.
Or on a plane. Let's not forget about planes.
Right. And making sure their experience is seamless no matter what. So we're talking caching strategies, running tasks in the background, knowing when to sync with the network. It's about reliability, even when the internet isn't cooperating.
Which brings us back to that whole data is king philosophy, right?
Yeah.
Having those solid data models in place makes it easier to handle these offline scenarios.
100%. You ever been filling out a long form in an app and it crashes, and then poof, all your progress is gone?
Ugh, the worst. Don't even remind me.
That, my friend, is often a sign of an app that hasn't prioritized data persistence.
Making me sweat thinking about all those banking apps I use.
But on a serious note, when you prioritize that persistent data, it's not just about a smoother user experience. It actually saves you, the developer, headaches down the line, because you're structuring your app in a way that anticipates the unexpected.
So how does a good architecture actually make all of this data management easier?
It's all about systems, right? A well-defined architecture, it ensures that data flows through your app in a predictable way.
Like a well-oiled machine.
Exactly. And that's where this idea of a single source of truth comes in, which sounds kind of philosophical, but it's actually incredibly practical.
Okay, break that down for me. Single source of truth. It sounds very zen, but what does it actually mean in the context of writing code?
So for any piece of data in your app, let's say a user's profile information, there should be one and only one place where that information can be modified. Not 2 places, not 3, just one.
So no more playing hide and seek with data. No more trying to track down which line of code is responsible for a rogue value.
Exactly. Having a single source of truth makes your code base infinitely easier to reason about.
I can see that. So what is that single source? Is it always a database?
It could be a database, it could be a view model, could even be the UI in some cases. The point is, you pick one and you stick with it. Consistency is key.
Got it. So we've got our solid data foundation. But how do we actually manage the flow of this data throughout our app? And this is where I've heard people throwing around the term unidirectional data flow, UDF for short,
You're right on the money. UDF is like setting up clear shipping lanes for your data.
instead of letting it slosh around like it's on a...
Like it's on a tilt-a-whirl.
Exactly. So tell me more about these shipping lanes. How does UDF actually work?
So imagine this. Data in your app. It follows a single predictable path, like a one-way street. When an event happens, like a user clicking a button, it triggers an update. And that update flows in a specific direction, eventually making its way to the UI. No more data bouncing around like a ping pong ball.
We're establishing order. Love it.
It's about creating a system where you can actually trace the path of data and understand how changes happen. And this actually brings us to the UI layer guide, which dives into building a modern, reactive user interface.
And by reactive, we're talking about UIs that respond to those data changes.
Yeah,
No lag, no jank, just a smooth, buttery experience.
you got it. And at the heart of this whole reactive UI idea are these things called stakeholders. And view model classes, they're often the stars of the show.
Okay, let's demystify stakeholders, because they seem to be everywhere these days.
Essentially, a stakeholder does exactly what its name suggests. It holds the state of your UI.
So if our UI is a play, the stakeholder is like the stage manager.
Exactly. Keeping track of all the props and cues, it manages the data that your UI needs to display, and it handles those events that can change the data user interactions, network responses, you name it. And then it tells the UI how to update based on those changes.
And view models, they're kind of like the VIPs of the stakeholder world,
They're definitely a popular choice. They fit really nicely into that whole UDF paradigm we talked about, and they play well with other parts of Android Jetpack.
which is Google's suite of libraries for Android development for anyone who's new to this.
Right. So it's less reinventing the wheel, more focusing on what makes your app unique, which is what we all want, right?
Absolutely. Nobody wants to be stuck writing boilerplate code when they can be building those killer features.
Exactly. And that's where this whole idea of UI state production comes in. The UI state production guide, it really digs into the how-to of updating your UI in a way that's efficient. And this is key predictable.
Because predictability in the world of software development equals sanity.
100%. So we're talking about understanding the life cycle of your app's UI, how to handle those asynchronous operations like network calls. It's about making sure your UI responds gracefully, even when things get a little messy.
Which, let's be real, they always do.
Always. But before we get too deep into UI state production, I'm curious, when you think about these stakeholders, how do they actually manage the logic behind our app's interface?
That's a great question. Because it's one thing to display data, but it's another thing entirely to make that data actually do something, right?
Right.
So we're talking about things like deciding when to show or hide elements based on what the user's doing, or handling things like scrolling behavior. All those little details that make our UIs feel interactive.
Exactly. And the cool thing is, you can handle a lot of this UI logic with simple stakeholder classes. You don't always need a full-blown view model if a straightforward approach does the trick.
Because why use a sledgehammer when a scalpel will do?
I like the way you think. Now, you might be wondering how this all ties back to Google's official recommendations, and that's where our next document comes in. Recommendations for Android architecture.
This is like getting the official rule book straight from the source. What are some of the key takeaways that stand out to you?
Well, this document is packed with wisdom, but one thing that really jumps out is the emphasis on dependency injection, specifically using a library called Hilt. Have you used Hilt before?
I've dabbled, but I'll admit dependency injection is one of those things that still makes me scratch my head sometimes.
It's one of those concepts that seems abstract at first, but once you wrap your head around it, it's a game changer.
So sell it to me. Why is dependency injection so important?
Think of it this way. As your app grows, so does the number of dependencies between different parts of your code, and Hilt basically becomes your personal assistant for managing all those dependencies.
Instead of our code looking like a tangled ball of yarn.
Exactly. It helps you keep things organized, makes your code cleaner, easier to test, and less prone to those weird, head-scratching bugs that pop up when dependencies aren't handled properly.
Speaking of testing, that's something I definitely want to dig into more. Because, let's be honest, nobody likes releasing buggy apps into the wild. And this is where a good architecture can really pay off, right?
100%. When your code is structured well, with clear separation of concerns and that whole data driving the UI thing we talked about, testing becomes so much smoother.
It's like you can actually test the engine of a car without needing to take it for a spin around the block.
Exactly. You can isolate individual components and test them thoroughly without having to worry about those cascading side effects.
Which are the worst kind of effects.
The absolute worst. For example, with a well-defined architecture, you can easily write unit tests for your view models, which, as we know, are often responsible for a lot of the logic in our apps.
And because those view models are separate from the messiness of the Android framework, we can test them without having to deal with emulators or the headache of UI testing.
You got it. It's about making testing as painless as possible, and a good architecture is the key. Now, speaking of well-defined architectures, the recommendations guide also talks a lot about this idea of a single activity architecture, which still trips me up sometimes.
Oh yeah, that one. It seems counterintuitive at first, right? Like
Yeah.
having a single activity for your entire app.
It goes against what a lot of us learned when we first started building Android apps. But think about the way modern Android apps work these days. Lots of smooth transitions, animations. It's all about that seamless navigation.
Instead of those abrupt jumps between completely different screens.
Exactly. A single activity architecture helps us achieve that by using fragments, or Jetpack Compose if you're feeling adventurous, to dynamically change the content that's displayed within that single activity.
So instead of switching between entirely different activities, we're essentially just swapping out the contents of that one main container.
Precisely. And this not only makes for a more fluid user experience, but it also plays really nicely with Jetpack navigation, which helps you manage all those complex navigation flows without pulling your hair out.
It's like we're not just improving the technical underpinnings of our app, we're actually making the user experience better at the same time.
Exactly. And here's where it gets really interesting. This single activity architecture actually complements that whole concept of UDF that we talked about earlier.
Oh, I see where you're going with this, because when you have that single activity as the central hub, it becomes a lot easier to manage how data flows through your app, right?
Exactly. And how events trigger those UI updates, it all just kind of clicks into place more naturally. Now, beyond these big picture architectural concepts, the recommendations guide also spends a surprising amount of time on what you might consider the small stuff, like naming conventions.
Ah, yes, the age-old debate of camel case versus snake case.
It's a classic for a reason, but seriously, the guide really emphasizes using meaningful and consistent names for your classes, methods, variables, all of it.
Because clear, readable code is happy code.
It makes a bigger difference than you might think. Good naming conventions make your code easier for others to understand, and let's be real, most real-world projects involve more than just one developer. Plus, it'll make it easier for your future self to understand what you were thinking when you wrote that code 6 months ago.
Because we've all been there staring at a piece of code and thinking, who wrote this?
Exactly. So it's about clarity, maintainability, making life easier for everyone involved. But I don't want to give the impression that these recommendations are just about dry technical details, because one of the things that comes through so strongly in this guide is the emphasis on crafting apps that are genuinely delightful to use.
It's about going beyond just making things work and focusing on that user experience, right?
Yeah, precisely. As developers, we have this incredible opportunity to create apps that people actually enjoy using. And it turns out that good architecture plays a huge role in that.
It's like the difference between, say, a meal that's just fuel and one that's a culinary experience, right?
Perfect analogy. And that's where all these principles we've been talking about, they come together to create that foundation, that solid base upon which you can build something truly special.
So we're not just slapping features onto a shaky scaffolding. We're carefully crafting an experience,
Yeah.
one that feels good to use.
Exactly. It's about recognizing that we as developers, we have a responsibility to create apps that are a joy to interact with, not just functional, but enjoyable.
It's about respecting the user's time and their sanity, let's be honest.
Absolutely. And, you mentioned earlier how the recommendations guide emphasizes making offline first apps. And this ties back beautifully to our discussion about data models.
Because when you prioritize how your app handles data offline, you're essentially creating a safety net for the user.
Right.
Right.
Exactly. So even if their internet connection drops out, the app doesn't just fall apart. It remains functional.
Yeah.
Any changes they make are saved locally and then synced later when they're back online.
No more lost data, no more frustration, just a smoother, more reliable experience.
Precisely. And this is another area where testing is so crucial.
Because we need to make sure that offline functionality is rock solid.
Exactly. And with a well-defined architecture, you can simulate different network conditions, test how your app behaves when it's completely offline. You're basically putting it through its paces before you unleash it into the wild.
Love that. So to kind of bring it all together, we've covered a lot of ground here. Persistent data, unidirectional data flow, single activity architecture, testing.
Mhm.
It's clear that all these concepts, they're intertwined.
They're all part of the same story, really. The story of how to build truly great Android apps.
Apps that are not just functional, but a joy to use. And to maintain, let's not forget about that part.
Absolutely. And the best part is that these principles, they apply whether you're building a simple to-do list app or the next viral social media platform.
That's what's so exciting about Android development. The same core principles can scale to any project. And Google's given us this amazing set of resources, this treasure trove of documentation.
It's like having a direct line to the Android team sometimes.
Right, so as we wrap up this deep dive, if you had to leave our listeners with one key takeaway, one architectural decision to really focus on, what would it be?
Ooh, that's a tough one. But I have to say it all goes back to data. Embrace the idea that data is king.
Because when your data layer is solid, everything else becomes so much easier.
Exactly. Spend the time to think deeply about your beta models, how they relate to each other, how they'll be used throughout your app, because that investment up front, it will pay off in dividends down the line.
It's about laying a strong foundation that can support all those amazing features you dream of building.
Couldn't have said it better myself.
So to all our listeners out there, that's a wrap on this deep dive into Android app architecture. We've explored the core principles from data persistence to the importance of testing and everything in between.
We've seen how these principles can help you build apps that are not only functional, but also scalable, maintainable, and a pleasure to use.
Because at the end of the day, we're not just writing code, we're crafting experiences.
Beautifully said.
And until next time, happy coding, everyone.